You've been practicing gas law problems for a while now, so let's see how you're doing. I want you to get out a piece of paper, a calculator, and a writing utensil. When a problem appears on the screen, I want you to pause the video and try to solve the problem for yourself. Then, once you have an answer, I want you to play the video and see if you got the correct answer. If you got the correct answer, awesome! I'm so proud of you. If you got the wrong answer though, just keep watching and I'm going to explain on the screen how you should have gotten the correct answer. Either way, after I've explained the correct answer, a new problem will come on the screen and you'll get to practice all over again. Hopefully this will show you whether you're a gas law master or still have some practicing to do before our quiz. So let's get started. Question number 1 asks you, if 1 liter of gas at standard temperature and pressure is compressed to 473 milliliters, what is the new pressure of the gas? So pause this video and come back once you've answered the question. All right, you should have gotten the correct answer of 2.11 atmospheres. Did you get it right? If you didn't, let's see how you should have gotten that answer. So our question remains the same. Now, when I read over the question, I noticed that it mentioned liters, which is my unit for volume. Then it tells me about standard temperature and pressure, which I know what both of those things mean. And then it gives me another volume. It then asks me what is the new pressure. So I'm given 2 volumes, and I'm given a pressure, and I'm asked about a pressure, which means I'm going to use the formula P1V1 equals P2V2. Now let's see what would have gone in what place. So my first pressure is 1 atmosphere because that is standard pressure. And I'm told that it is 1 liter of gas at standard pressure. So that is my P1 and my V1. Now for my P2, that's what I'm being asked to solve for. It asks me what is the new pressure. Now somewhere you may have gone wrong is although volumes can be in milliliters or liters, they both need to be in the same thing, either liters or milliliters, but we can't have one in each. So I chose to convert my milliliters to liters and made it 0.473 liters. Now I'm left just solving for P2, which I accomplish by dividing by 0.473. And that should have gotten you your answer of 2.11 atmospheres. Let's try another one. This time you're told the temperature inside my refrigerator is about 4 Celsius. If I place a balloon in my fridge that initially has a temperature of 22 degrees Celsius and a volume of 0.50 liters, what will be the volume of the balloon when it is fully cooled by my refrigerator? Pause this video and come back when you have your answer. You got this question correct if you got an answer of 0.47 liters. Didn't get that answer? Then let's see how you should have gotten it. Once again, our question is remaining the same. But when I read through my question, I'm told about a temperature, 4 degrees Celsius. I'm then told about another temperature, 22 degrees Celsius, and I'm told about a volume, 0.5 liters. I'm then asked, what will the volume be? So I'm given 2 temperatures, a volume, and asked about a volume, which means I'm using V1 divided by T1 equals V2 divided by T2. Now, something that may have caused you some difficulty is remember, in all gas law problems, temperatures need to be in Kelvin every time. So before I can move forward, I needed to convert those 2 Celsius temperatures into Kelvin temperatures. So I took 22 degrees Celsius and added 273 to make it 295 Kelvin, and I took 4 degrees Celsius and added 273 to make it 277 Kelvin. Now I'm ready to plug into my formula and solve for my unknown. So that means I'm going to have 0.5 liters divided by 295 Kelvin, and that's going to be equal to my V2, which is what I'm solving for, divided by my 277 Kelvin. I'm then going to solve for my V2, get it on a side all by itself, and that is how you should have gotten your 0.47 liters. For question number 3, we are told a bag of potato chips is packaged at sea level, which has a pressure of 1 atmosphere, and has a volume of 315 milliliters. If this bag of chips is transported to Denver, which has a pressure of 0.77 atmospheres, what will the new volume of the bag be? Pause this video and come back when you have an answer. You got the correct answer if you got 406 milliliters. If you got it right, awesome job. If you got it wrong, let's see where you went wrong. So once again, question doesn't change. But when we read through it, we see that we're told about a pressure, 1 atmosphere, and we're told about a volume, 315 milliliters. I'm then told about a second pressure, 0.77 atmospheres, and I'm asked about the volume, which means I'm once again using P1V1 equals P2V2. So I'm going to plug into my formula where 1 atmosphere times 315 milliliters is going to equal 0.77 atmospheres times V2. I need to get V2 on a side by itself, so I'm going to divide both sides by 0.77 atmospheres to get a V2 of 406 milliliters. Question 4 asks us, if I have 4 moles of gas at a pressure of 5.60 atmospheres and a volume of 12.0 liters, what is the temperature? Pause this video and come back when you have an answer. All right, you got the correct answer if you got 205 Kelvin as your answer. If you didn't get this answer, keep watching. So we have our question, and when we read through, we noticed that we had a number of moles, a pressure, and a volume. Now, some of you may have struggled to figure out what gas law you needed to solve this one. But this one was using our ideal gas law, which I call PIVNERT because it's PV equals nRT. Now, when we read our problem, we can see that we have a number of moles, N. We are given a pressure, we're given a volume, and you know that R is a constant, so I don't have to give it to you because you already know what it is. So then we are just being asked to solve for a temperature. So this is really no different than the 3 problems we've worked so far. So we're going to plug everything in, where I have my pressure of 0.56 atmospheres times my 12 liters. And then I have my 4 moles times R, my constant, 0.0821, to solve for my temperature. And that's going to get me my temperature of 205 Kelvin. If that one was a little tricky for you, it's okay, but don't miss an ideal gas law the next time it comes around. Question 5 tells us that in a thermonuclear device, the pressure of 0.05 liters of gas within the bomb casing reaches 4.0 times 10 to the 6 atmospheres. That's a big number. When the bomb casing is destroyed by the explosion, the gas is released into the atmosphere where it reaches a pressure of 1 atmosphere. What is the volume of the gas after the explosion? So pause this video and come back when you have an answer. All right. You should have gotten an answer of 2.0 times 10 to the 5th liters. If you didn't, let's see where you went wrong. So this was a simple P1V1 equals P2V2. And as you're reading your problem, this should have become apparent. Now the first sentence can be a little confusing because it tells you the pressure of 0.05 liters. But that's not really telling you the pressure, that's the volume, because you know liters is a measure of volume. So when we keep reading, it tells us the pressure of that volume reaches 4.0 times 10 to the 6 atmospheres. As we keep reading, we then see that after the explosion, it's going to reach a pressure of 1.0 atmospheres, and it's asking us to solve for volume. So we plug in everything to our formula, and we're going to solve for our V2, which should have been 2.0 times 10 to the 5th liters. Question 6 tells us a man heats a balloon in the oven. If the balloon initially has a volume of 0.4 liters and a temperature of 20 degrees Celsius, what will the volume of the balloon be after he heats it to a temperature of 250 Celsius? Did you get the right answer? You did if you got 0.71 liters. Let's see how we would have gotten that answer. So when I read my problem, it becomes apparent that I'm given a volume, 0.4 liters, and a temperature, 20 degrees Celsius. And then I'm being asked about the volume, and I'm being given a second temperature. So that means that I have a V1 divided by T1 equals V2 divided by T2 problem. Somewhere you may have went wrong is remember in all gas law problems, temperatures need to be in Kelvin. So my first step is to convert my Celsius temperatures to Kelvin. And I do that by adding 273 to both. So now instead of 20 degrees Celsius, I have 293 Kelvin. And instead of 250 Celsius, I have 523 Kelvin. Then I'm just going to plug my numbers into my problem. So I have my V1, 0.4 liters, divided by my T1, 293 Kelvin, equals my V2, which I don't know, I'm solving for it, divided by my T2, which is 523 Kelvin. Once I get V2 on a side by itself, it is 0.7 liters. Question number 7 tells us that a Los Angeles-class nuclear submarine has an internal volume of 1.1 times 10 to the 7th liters at a pressure of 1.25 atmospheres. If a crewman were to open one of the hatches to the outside ocean while it was underwater, which is a horrible idea, by the way, keeping in mind the outside ocean pressure is 15.75 atmospheres, what would be the new volume of air inside the submarine? Hint, not going to be good. So pause this video and come back when you have an answer to this disastrous question. All right, you should have found that the new volume of air is going to be 870,000 liters, or you could have put it in scientific notation as 8.7 times 10 to the 5th liters, which may seem like a pretty large volume, and in the big picture it is. But when you're talking about all of those people on a submarine, that is not going to be enough room for everyone. So, not great. If you didn't get this answer though, let's take a look at how you would have gotten it. So this was a simple P1V1 equals P2V2 problem. I was told a starting volume, 1.1 times 10 to the 7th liters, and I was given a starting pressure, 1 times 0.25 atmospheres. I was then told a second pressure, 15.75 atmospheres, and asked what would the new volume be. So I plug everything into my formula, I get my V2 on a side by itself, and I get my correct answer. These should be getting easier for you as they go along. If they aren't, feel free to reach out to me and I will be glad to work with you on any of these problems. So question number 8 tells us that if I have an unknown quantity of gas at a pressure of 1.20 atmospheres, a volume of 31 liters, and a temperature of 87.0 Celsius, how many moles of gas do I have? Pause this video and come back when you have an answer. All right, hopefully this one didn't trick you a second time it came around. You should have gotten a correct answer of 1.26 moles. Did you get it? If not, let's see how you should have done it. So when you read over this problem, it becomes apparent that you have a pressure, a volume, a temperature, and you're being asked about moles. What all 4 of those things have in common is the ideal gas law, Pivner. Something that may have tricked you up on this one is, once again, remember all temperatures need to be in Kelvin. So my first step was to convert my temperature to Kelvin. So I took my 87 degrees Celsius, added 273 to get 360.0 Kelvin. From there, I plug into my formula where I have my pressure of 1 atmosphere times my volume of 31 liters equaling N, my number of moles that I'm trying to solve for, times R, which is my constant, 0.0821, times my temperature, which in this case was 360 Kelvin. Once I get N on a side by itself, I should have gotten my 1.26 moles. For question number 9, we are told that synthetic diamonds can be manufactured at pressures of 6.00 times 10 to the 4th atmospheres. If we took 2 liters of gas at 1 atmosphere and compressed it to a pressure of 6.00 times 10 to the 4th atmospheres, what would the volume of that gas be? Pause this video and come back when you have an answer. Congratulations to those of you who got a correct answer of 3.33 times 10 to the negative 5th liters. So a super small amount. That's because that's a really big pressure, so that makes a lot of sense. If you didn't get this answer, let's see how you should have gotten it. So as I read through my problem, I see that I'm given a volume and a pressure, and then I'm given a second pressure and being asked to solve for the volume. So that means I'm using my friend P1V1 equals P2V2, where I'm going to plug in my numbers from I was given in my problem into it. Then I'm going to get my V2 on a side by itself, and it should get you the correct answer. Question number 10 tells us that on hot days, you may have noticed the potato chip bags seem to inflate, even though they have not been opened. If I have a 250 milliliter bag at a temperature of 19 degrees Celsius and I leave it in my car, which has a temperature of 60 degrees Celsius, what will the new volume of the bag be? Pause this video and solve this problem on your own. Come back when you have an answer. The volume of my new bag is going to be 285 milliliters. If you got it right, I'm super proud of you. If you didn't, let's take a look so you can do better next time. So my question remains the same. And I notice that I am told a volume of a bag and a temperature. I am then told a second temperature, and I'm asked about the new volume, which means I know I'm using V1 divided by T1 equals V2 divided by T2. And I also know, especially by now, that all my temperatures need to be in Kelvin. So my first step is to take those 2 Celsius temperatures and turn them into Kelvin by adding 273 to both of them. So now, instead of 19 degrees Celsius, I have 292 Kelvin, and instead of 60 degrees Celsius, I have 333 Kelvin. Then I'm going to plug into my formula, and I'm going to solve for my unknown, which in this case is my V2, and that's going to get me my 285 milliliter answer. For question number 11, a child has a toy balloon with a volume of 1.80 liters. The temperature of the balloon when it was filled was at 20 degrees Celsius, and the pressure was 1 atmosphere. If the child were to let go of the balloon and it rose 3 kilometers into the sky, where the pressure was 0.667 atmospheres and the temperature was negative 10 degrees Celsius, what would be the new volume of the balloon? Pause this video and solve this problem on your own. Come back when you have your answer. You got the correct answer if you figured out that it would have a volume of 2.42 liters. Did you get it right? Great. If you didn't get it right, this one was a little tricky, so I understand. So when we read through our problem, we notice that we're told a volume, a temperature, and a pressure. We're then told this information about 3 kilometers, which may have stumped some of you, but it actually wasn't information you necessarily needed, or at least not the 3 kilometers part. We're then told another pressure, another temperature, and ask about a new volume. which means we're using P1V1 divided by T1 equals P2V2 divided by T2, our combined gas law. As always, all of our temperatures need to be in Kelvin, so right off the bat, I add 273 to both of them to take 20 degrees Celsius to 293 Kelvin and to take negative 10 Celsius to 263 Kelvin. From there, I'm still just plugging into my formula like I have for all of my other problems so far. So as I read my problem, I'm filling in my information into the appropriate part of the formula. I can see that my starting pressure was 1 atmosphere with a starting volume of 1.8 liters, and that all happened at 20 degrees Celsius, which we determined to be 293 Kelvin. That's going to equal my new pressure, which I was told was 0.667 atmospheres. I'm being asked to solve for that new volume, and my new temperature, my T2, was that negative 10 Celsius, which I determined to be 263 Kelvin. I'm going to solve for V2 and get my 2.42 liters. Question 12 wants to know that if I contain 3 moles of gas in a container with a volume of 60 liters at a temperature of 400 Kelvin, what is the pressure inside the container? Pause this video and come back once you've answered this question. The correct answer to this question is 1.64 atmospheres. Let's see how we would have gotten that answer in case you didn't get it correct. So as I read through my problem, I see that I was given a number of moles, a volume, a temperature, and asked about a pressure. Those 4 things can only be found together in our ideal gas law, PIV-NERT. Now, right off the bat, my temperature is already in Kelvin, so I'm good to go there. So it is just time to plug everything in. So I plug in my numbers to where they belong in my equation. I'm solving for the pressure. So I get pressure on a side by itself to get my answer of 1.64 atmospheres. Question 13 raises the question of the highest pressure ever produced in a laboratory setting was about 2.00 times 10 to the 6 atmospheres. That's a lot of pressure. If we have a 1.00 times 10 to the negative 5th liter sample of gas at that pressure, then release the pressure until it is equal to 0.275 atmospheres, what would the new volume of that gas be? Pause this video and come back when you have an answer. You got the correct answer if you got 72.7 liters. Let's see how we would have gotten that answer. So when I read my problem, I see that I have a pressure and I have a volume. I'm then given another pressure and asked about my new volume. So it's our good friend P1V1 equals P2V2. I'm going to plug in my variables where they belong, where I started with that super intense pressure, and I'm going to multiply it by that super small volume. It's going to equal that new pressure, which is even less pressure than you and I are under right now in our homes, to find out what that new volume is going to be, and you should get 72.7 liters. For question 14, we're told that a soda bottle is flexible enough that the volume of the bottle can change without opening it. If you have an empty soda bottle with a volume of 2 liters at room temperature, which is 25 degrees Celsius, what will the new volume of it be if you put it in the freezer, which your average freezer is about -4 degrees Celsius. So pause this video and come back once you have your answer. The new volume of our soda bottle is going to be 1.81 liters. If you got it right, move on. If you got it wrong, let's see how we got our answer. So when I read my question, I notice that I'm given a volume and a temperature. I'm asked about a new volume and given a new temperature. So that means I'm using V1 T1 divided by T1 equals V2 divided by T2. And instantly I know by now that all my temperatures need to be in Kelvin. So the first thing I do is add both of my Celsius temperatures to 273. so that 25 degrees Celsius becomes 298 Kelvin, and negative 4 degrees Celsius becomes 269 Kelvin. From there, I plug my numbers into my problem, where I have my V1, which is 2 liters, divided by my T1, which is 298 Kelvin, equaling my V2, which I'm solving for, so I don't know what it is, divided by my T2, which is going to be 269 Kelvin. And once I've got my V2 on a side by itself, it should equal 1.81 liters. All right, last question. You should be getting these right by now, and if you're not, make sure to check in with me because I'll be glad to help you out. So we are told that a commercial airliner has an internal pressure of 1 atmosphere and a temperature of 25 degrees Celsius at takeoff. If the temperature of the airliner drops to 17 degrees Celsius during flight, what is the new cabin pressure? Pause this video one last time and come back when you have the answer. Our new cabin pressure on this flight is going to be 0.973 atmospheres, so just a little bit lower. Hopefully you got it right, but if you didn't, let's see what you should have done. So when I read my problem, I see that I have a pressure and a temperature, and then I see that I'm given another temperature and asked about my new pressure, which means that I'm going to be doing P1 divided by T1 equals P2 divided by T2. Right off the bat, I know that those Celsius temperatures need to be converted to Kelvin, so I do that first by adding 273. From there, I'm plugging my numbers into my formula that I got from my problem. Then I'm going to get P2 on a side all by itself to get my 0.973 atmospheres. Hopefully, this video gave you some practice that you needed, and now you're a gas law expert. If you're still struggling with these problems, please reach out to me. I'll be glad to work with you and help you out so that you can get better at these.